Today, we're diving into something that feels a bit like magic, but is actually pure statistics. We're going to break down how researchers can figure out what millions of people are thinking by only talking to 1,000 of them. It all comes down to three core techniques: simple random, stratified, and cluster sampling. Let's get right into it.
I mean, it's a fantastic question, isn't it? You see a poll and think, how could they possibly know that? Whether it's for an election, market research, or a big scientific study, they obviously can't talk to every single person. So they have to pick a smaller group to represent the whole. And how they pick that group, well, that changes everything.
The secret sauce behind all of this is something called probability sampling, and the main idea is actually pretty simple. Every single person in the bigger group, the population, has to have a chance of getting picked. It's not about convenience, like asking people you happen to run into. It's all about randomization. That's what gives the results their power and credibility.
So here's our game plan. We'll start with the basics, simple random sampling. Then we'll get into the more advanced stuff with stratified and cluster sampling. And finally, we'll put those two head to head to really iron out the differences, because that's where people often get tripped up. All right, first up is the one that sets the standard, the method that all the others are compared against. This is simple random sampling, and it's all about one thing: pure, unfiltered chance.
The definition is just as straightforward as the name. Every single person, every element has the exact same shot at being chosen. It's the ultimate equal opportunity system. You know, in statistics, they even have a fancy acronym for this: EPSM, which stands for Equal Probability Selection Method. And honestly, this is the best way to think about it. It really is that simple in concept. Now, of course, researchers aren't using a literal hat these days. They're using random number generators on a computer. But the core principle? It's exactly the same. Pure luck of the draw. So why do people love it? Well, its biggest plus is its simplicity. It's easy to understand, usually pretty cheap to do, and because it's totally random, it does a fantastic job of kicking selection bias to the curb. If all goes well, you end up with a sample that looks like a perfect little miniature of your entire population. But, and it's a big but, it's not perfect. For one, you need a full list of every single person in the population, and that's often impossible to get. Plus, what if you're interested in a group that's really rare? By pure chance, you might not pick any of them, and that's a huge problem if that group is important to your study. This limitation is exactly why we need other methods. So, what do you do when you absolutely have to make sure certain groups are included in your sample? Well, that's when you turn to stratified sampling. This technique is all about taking control and guaranteeing precision. Think of it as a careful two-step process. First, you, the researcher, divide the entire population into specific, non-overlapping groups. These are called strata. The goal is to make each group really similar on the inside, like grouping people by age range, for example. Then you do a simple random sample within each and every one of those groups. And the payoff for this extra work is huge. You guarantee that every important subgroup is represented. This seriously boosts your precision and lets you analyze each group on its own, which can uncover insights you would have totally missed otherwise. Of course, that level of precision comes at a cost. This method is way more complex. You have to know a lot about your population just to create the groups in the first place, and that can be really difficult, time-consuming, and expensive. It's a classic trade-off. You get more control, but you have to put in a lot more effort. Now, this is where stratified sampling gets really powerful. You've got two main strategies. With proportionate sampling, you basically create a perfect mini-me of the population. If 80% of the country is female, then 80% of your sample will be female. Easy enough? But what if a group you care about is only, say, 1% of the population? A proportionate sample would be tiny. That's where disproportionate sampling comes in. You can intentionally oversample that tiny group to make sure you have enough people to actually study them properly. It's a real game changer. And as you can see here, it can get even more sophisticated. Researchers can get super strategic about how they allocate their samples. They can design it to get the most precision for their money, or to get the job done at the lowest possible cost. It's an incredibly flexible and powerful tool when you have very specific goals. Okay, on to our third method. This one solves a massive real-world problem. What if your population is spread out all over the country, or even the world? It would cost a fortune to try and randomly sample individuals. And that's exactly where cluster sampling comes to the rescue. It's all about practicality and saving money. The key idea here is naturally occurring groupings. Unlike strata, which researchers create, clusters already exist out in the wild. Think cities, schools, hospitals, neighborhoods. So instead of picking individuals, you first randomly select a handful of entire clusters. And then you go into only those chosen clusters to get your sample of people.
The benefits here are all about logistics. It is so much cheaper and easier to pull off. You don't need a list of every single person in a country, just a list of its cities. And your research team only has to travel to, say, 10 cities instead of 500 different scattered locations. This is what makes massive nationwide surveys even possible.
But there is a catch. That convenience can come at the cost of precision. If the few cities you happen to pick aren't really representative of the country as a whole, your results could be way off. This method usually has a higher chance of error than the other two we've talked about. Okay, this is the main event, stratified versus cluster. A lot of people mix these two up because they both use groups, so let's put them side by side and make the differences absolutely crystal clear.
This table breaks it down perfectly. Just look at the objective. You choose stratified when you need precision. You choose cluster when you're worried about cost and logistics, and that main goal changes how you do everything. With stratified, you sample a few people from every single group. With cluster, you do the opposite. You pick just a few groups and then sample a bunch of people inside them. It's a completely different approach.
And this right here, this is the real aha moment. Think of it like this. For stratified sampling, you want to create groups that are super similar on the inside, but very different from each other, like sorting M&Ms into separate piles by color. The blue pile is all blue, the red pile is all red. Homogeneous inside, different between. For cluster sampling, you want the exact opposite. You want each cluster to be a diverse little mini population all on its own, a small bag that has all the different colors of M&Ms inside. Each bag should look just like all the other bags.
So, after all that, what's the big takeaway? Well, it's pretty simple, really. There is no single best way to do this. It is all about picking the right tool for the right job.
So here's your cheat sheet. If you want a simple, unbiased starting point and you have a good list, go with simple random. If you have specific subgroups that you absolutely must have a good read on, you need the power and precision of stratified sampling. And if you're dealing with a huge population spread all over the map and you're on a tight budget, cluster sampling is your lifesaver.
And that really brings us to the final point. The quality of any poll, of any study, rests entirely on how they chose the people they talked to. So now, the next time you see a headline with a big new statistic, you have the tools to ask the most important question. How did they get their sample? Because understanding the method tells you almost everything you need to know about what the numbers really mean.